Now, ladies and gentlemen, when we're talking about percent comp, we are just dealing with how much of each individual element is in that compound. Okay? How much of the element is, in this case, potassium? How much of the element is phosphorus? How much of the element is oxygen? Or excuse me, out of the compound. How much of the compound is phosphorus? How much of the compound is potassium? How much of the compound is oxygen? So, where we need to start off is we need to calculate the molar mass. So, what I need you to do, after you write down this question, calculate the molar mass, and then we will go from there. Okay, first of all, my formula is K3PO4, and my molar mass is 212.2663 grams per mole. So, how I work these problems, folks, is I take each individual element and I say, okay, potassium. All right, I have 3 potassiums. Each one of them are, each potassium is 39.0983. 0983. So if I have 3 of those at 0.0983, that gives me 117.2949, correct? Now, in order to calculate how much percentage that is, I just simply take the total. Multiply by 100. And let's say, how far do we take it out? Let's just take it to 3 significant digits. Okay, so I'm going to take this 55.3%. I'm going to do the same thing for potassium. There's only one potassium. There's only one potassium. So, 31.9738. So I take the 31.9738, divide it by the total mass again, times it by 100 to put it into a percentage. That is 15.1% would be potassium. Then finally, my oxygen. I have 4 oxygens. Each oxygen is 15.9994. What? Dang it. I'll go back to that. So when I do this, I take the 63.9976, I divide that by the 212.2663, multiply by 100. That gives me 30.1% to 3 sig figs. Now, let me go back and get out my little cheaters. Yeah, you know what? I did this. Potassium phosphorus oxide. Oh, okay. 30, not 31, right? That number right there is 30, not 31. 30.9738. Is that what we're looking? Yay? 30.9738 divided by 212.2663. How about 14.6 sound better? 14.6 sound better? Now, when I go through, how do I check this, folks? I see if they add up to be 100. So 55.3 plus 14.6 plus 30.1 gives me 100 on the nose. Now, do I have to get 100 on the nose? Okay, why don't I? Okay, I'm rounding figures, right? So I'm not going to get 100 on the nose every time. This one worked out pretty good. So we got 100 on the nose there. All right. Any questions over this first one? Here's another one. I threw an acid on there. So go ahead and name that one and find your molar mass. The chemical formula for manganic acid, H2MnO4. When I calculated my molar mass, I came up with 120.9514 grams per mole. So, I'm just going to start off with hydrogen. I know that there are 2 hydrogen. Each hydrogen's 1.0079. So, that gives me 2.0158 grams total of hydrogen. How many of the 120.9514? What percent? .67% of that is hydrogen. Manganese, I only have 1 manganese, and that is 54.9380, correct? So when I do my math, I'm going to get 45.4% of that compound is manganese. And then I'm going to finalize with oxygen. 4 times 15.9994. $63.9976. It's going to give me 52.9%. And this is one where when I add them all together, I get 99.97. Is that close enough to think that, yes, I'm okay? I believe. I believe. I am just rounding everything right now to 3 sig figs. Okay, just randomly. Okay? Now here's my next problem. Go ahead and copy this down and we'll talk about it. A sample of benzene is analyzed and found to consist of 13.74 grams of carbon and 1.150 grams of hydrogen. What is the percent composition of benzene? Well, they give me the mass of each individual substance. Do I even need to know what the formula of benzene is? Do I even need it? No, I do not. So what I am going to do, first of all, is I am going to calculate what my total mass is. 13.74 and 1.150. So when I get my total mass, it's going to be 14.890 grams. Would we agree on that? So, all I'm going to do is take each individual one. Carbon, 13.74 out of the 14.890. Multiply that by 100. And that is going to give me and I'm doing this one, folks, to 97 point, excuse me, check, 92.28%. Now I'm taking this to 4 significant figures because both of my values up top have 4 significant figures. So I have done my carbon. Now I am going to do my hydrogen. So hydrogen has 1.150 out of the 14.890. Multiply that by 100 to put it into a percentage. 1.150, 14.890. Multiply by 100. And that gives me 7.723 to 4 sig figs. When I add those two values together, I get 100.003. I say that's close enough that I got that one right. Now let me check out. Are we okay with this one? We good? All right, see a lot of nodding, so I say okay. Let me check out my last example to see. Go ahead and work this one on your own, and then I will work it. Work this on your own, I'll work it, see if we come up with similar answers. Okay, when I did my math, I came up with a total mass of 32.25. Sound good? So, I'm going to start out, I'm just going to go in the order that they list them. 21.8 grams of that is oxygen. So 28.1 grams of the 32.25. So I come up with 67.6% oxygen. Aluminum, 4.09 of the 32.25. .7% aluminum. Nitrogen, 19.7% nitrogen. And I hit 100 right on the nose when I do my check.